Okay, so today we'll solve GET 2018 question. This is a question from functional analysis. It's question number 47. So it's saying that let L2 0 over 0, 1 be the Hilbert space Hilbert space of all real valued square integral functions on closed 0, 1 with the usual inner product, and phi be the linear functional on L2 closed 0, 1 defined by phi of f is given by this integral, where mu is the Lebesgue measure on 0, 1. Then you have to find the norm of this linear functional phi. Okay. Okay, so this is the NPTEL reference. This you can look into it. Okay, so let's try to solve this one. So L2 0, 1. So this is all functions such that integral 0 to 1 mod fx d mu x, this is the Lebesgue measure on 0, 1 square, this should be finite. And what is the norm? F L2 norm, it is defined to be 0, 1 mod fx square d mu x for half. And what is the inner product for f in G in L2 0, 1? F inner product G is defined to be 0, 1 fx gx d mu x. Okay, now here phi is a linear functional is given. So before that, for that we have to find the norm of this phi. So for that we will use the ridge representation theorem. So let me write it first. So I am writing it ridge representation theorem for this Hilbert space only L2 0, 1. So let T be a bounded linear functional on L2, 0, 1. Then there exists unique G in L2, 0, 1 such that T, which is mapped from L2 0, 1 to R, is given by T of f equals to 0 to 1 fx gx d mu x with norm t, this is functional norm of t, is same as g of L2 norm of g. right? So this is ridge representation theorem, saying that any linear functional on L201, it will be given by the inner product with some unique function g, and the functional norm of t is same as the L2 norm of g. So we'll use this to calculate the L2 norm of this functional. Okay. So here we have P, this is a linear functional 0, 1 to R, which is P of F 1 by 4 to 3 by 4, 3 root 2 F d mu, means fx d mu x. So in order to calculate the norm phi, first to use the ridge representation, we have to show that this is a bounded linear functional. So let's check that why t is bounded, phi is bounded. To check phi is bounded linear function. Linearity is clear, right, by the definition. P is linear. Now let's check that P is bounded, means P of F. So this is 1 by 4 to 3 by 4, 3 root 2 F x dx. 3 root 2 we can take it out. And this we have, I have also make less than 1, take the mod inside. So this is mod of fx d mu x. Now using Cauchy-Schwarz, by Cauchy-Schwarz inequality, so what we will get? So Cauchy-Schwarz inequality, this 3 root 2, so this should be less than. So we are applying Cauchy-Schwarz this with the 1 function. So this is 1 by 4 to 3 by 4 mod fx square d mu x to the power half times 1 by 4 to 3 by 4 1 d mu x to the power half. So let me write the Cauchy-Schwarz inequality. What is the Cauchy-Schwarz inequality? Because there will be easy. So Cauchy-Schwarz inequality. So it is saying that mod fx gx d mu x, suppose this is a Hilbert space over H, this is less than 1 over H mod fx square d mu x to the power half H mod gx d mu x to the power half. So this is the Cauchy-Schwarz inequality. So we have used this one. So note that this is the right hand side, you can write it. So what is the L2 norm of what if you calculate this, what you will get? So this is the integration from 3 by 4 minus, so if you calculate this one, what you will get? 1 by root 2, I think. So 3 root 2, this will be 1 by root 2, and this I am dominating by from 0 to 1 I make it, because this is bigger, d mu x. So therefore what we get? 3, this is the L2 norm of f over 0 1. So we get P of f is less than 3 times L2 norm of f, and this is true for all f in L2 0 1, which implies P is bounded linear functional. So we can use the Ridge representation theorem. So then by Ridge representation theorem, we can calculate its norm. Now we have to first write it in terms of, so this will be given by some inner product with some L2 functions as P of f, this is 1 by 4 to 3 by 4, 3 root 2 f x d mu x. This you can write 0 to 1, 3 root 2, and characteristic function of 1 by 4 to 3 by 4 x, let me write it, fx, this one with d mu x. Let me call it g, 0 to 1 fx gx d mu x, where gx is 3 root 2 characteristic function of 1 by 4 3 by 4. So characteristic function means it's 1 in this interval 1 by 4 to 3 by 4 and 0 outside. Okay, so first note that why g is in L2. Note g is in L2. Why? L2 0 1. So let's calculate L2 norm of g. So what it will be if you put, so 3 root 2 so it will be 18 and because of this characteristic function the limit will be 1 by 4 to 3 by 4 d mu x. Hence it will be 18 times 1 by 2 to the power half. So it's square root 9, so 3. So this is finite. So G is in L2. Now ridge representation thing is, so we get what we get. We get P of F is given by F inner product G, where G is in L2. And ridge representation saying that this P of should be given by F inner product G for unique G. So this should be the G. So by ridge representation theorem, norm of P will be the L2 norm of G. And we have calculated this L2 norm of G. What is this L2 norm of G? This is 3. So therefore, non-P is 3. Okay, so 3 is the correct answer. So therefore non-P is 3. Okay.